Now it's difficult to actually compare these directly. Compare, for example, this 3.3 against this 0.1, because these are the slopes of the line, but they're all obviously all measured on different scales. Age in years, gender, income, they're all measured on completely different scales. So this is where these standardized coefficients come in. It's called betas. And these are the same things reflected not in the absolute scores, but in terms of standard deviations. So, in other words, as age increases by one standard deviation, depression score decreases by minus 0.1 of a standard deviation of depression score. Okay, so everything is standardized. It's standardized in terms of standard deviations. So as gender changes by one standard deviation, depression score goes up by 0.07 of a standard deviation in depression score. Now the key part is this part of the table here, significance. Now this tells us whether the amount of variance, the amount of work that each of the predictive variables is doing is actually significant. So for age, the significance value is 0.6, which tells us that age actually isn't providing a significant prediction. So the amount of variance that age is explaining, in other words the slope of this line, is not significantly different from 0. And the same for gender, it's 0.7. Now when we move on to income, however, we find P equals 0.008, which obviously is less than 0.05, so it's significant. Now this tells us that although we have this model that includes these three variables, it's actually only income that has any predictive value. So what we would conclude from this is that as income increases, depression score decreases. Okay, so every £1 extra income reduces depression score by 0.09 of a point. Every increase by one standard deviation in income reduces depression score by 0.6 of a standard deviation.